Hello students, I am Mr. Adinath Badar, Assistant Professor, Department of Chemistry, late Pushpadevi Patil, Arts and Science College, Risod, Dist, Washim. Today I am going to discuss the topic for B.Sc first, Unit second, Part B, that is PBlock elements, lecture number first. So firstly, we see what is the PBlock elements and its position. So simply, the p-block elements are placed in a periodic table from 30th group to the 18th group, or also called the elements which last electron goes in p orbital, called as p-block elements. The general electronic configuration is ns2 np1 1 to 6. The ns2 np1 to 6. The groups included in the syllabus are 13, 15 and 16th group elements. Here these are the position of p block elements in periodic table, placed at right side in a periodic table having total 6 group, that is 13th, 14th, 15th, 16th, 17th and 18th group. These are the first p block element group, that is 13, or also called boron family, having elements boron, aluminium, gallium, indium and thallium. Second group is carbon family, or called as 14th group, elements having carbon, silicon, germanium, stannous, lead. Third group is 15th group, or called nitrogen family, having element nitrogen, phosphorus, arsenic, stilbene and bismuth. The fourth group is 16th group, or also called oxygen family, having elements oxygen, sulfur, selenium, tellurium and polonium. The fifth group is called 17th group, elements are also called halogen family, having elements fluorine, chlorine, bromine, iodine and yttrium. And the last group is called 18th group, or noble gas elements, having elements helium, neon, argon, krypton, xenon and radon. Here these blue color elements are non-metal, these yellow color elements are metalloids, and these dark yellow color are metals. Here these are the non-metal, these elements are metalloid and these one are metals. So non-metals means it always show electronegativity character. Metals always show electropositive character, and these metalloids are shows metal as well as non-metal character. Then it is called metalloid. Then it is called metalloid. So firstly we see the comparative study of group 13th element. So 13th group elements are also called third A group elements, or boron family, having five elements, that is boron, aluminium, gallium, indium and thallium. These are the symbol for this element BALGAINTL, having atomic number 5, 13, 31, 49, 81, and these are the electronic configuration for these elements, that is 2s2 2p1 3s2 3p1 3d10 4s2 4p1 4d10 5s2 5p1 4f14 5d10 6s2 and 6p1. These are the valence shell electronic configuration. these are the valence shell electronic configuration: 2s2 2p1, 3s2 3p1, 4s2 4p1, 5s2 5p1, 6s2 6p1. Means the last electron r goes in p orbital in all elements. That's why these elements are called p-block elements, and these are the outer shell electronic configuration having one electron in p orbital in all elements from boron to thallium. Now the next property is ionization energy. So we know the ionization energy is decreases as we move from top to bottom. As we move from top to bottom means as we move from boron to thallium, the ionization energy value will be decreases. Here the first ionization energy value are mentioned. Here boron shows 798, aluminum show 576, gallium shows 577, indium shows 556, and thallium shows 589. These are the exceptional case due to inert pair effect, but in general the ionization energy value goes on decreases from top to bottom. Our first ionization energy value goes on decreases from top to bottom, as like same second ionization energy. Here boron shows 2419 and thallium shows 1954. Here also the values goes on decreases as we move from top to bottom. Here in the third ionization energy also this value are goes on decreases from top to bottom, that is boron to aluminum, gallium, indium and thallium. These are the general trend, but some elements are shows exceptional value due to the inert paired effect. Now the next topic is diagonal relationship between beryllium and aluminum. Beryllium is the first element of second A group element, shows some similarities in some properties with aluminum, that is third A group element. The second typical elements in the next third A of the next higher period. This type of periodicity between these elements on account of their relative position in a periodic table. Here these are the second period and third period. Here second A group, that is S block element, here beryllium, and these are the third A group elements or P block elements. The second elements of 13th group, that is aluminum, and first elements of second A group, that is beryllium, shows some similar properties or similarities in some properties. Some of the known properties, that is here the oxidation potential of these both two elements are nearly or near about same, that is beryllium have a oxidation potential is 1.70 volt and this aluminum shows 1.67 volt. The next properties is both beryllium and aluminum form many stable complexes with ligand. The beryllium the beryllium oxide and aluminum oxide are amphoteric. They dissolve in acid as well as alkali. On reaction with alkali, they form berylliate and aluminates, and these similarities between these two elements are called diagonal relationship between beryllium and aluminum, or second A group elements and third A group elements. Now the next or last property is oxidation state. Last property is oxidation state. Oxidation state, although the removal of all three electrons from the gaseous atom is very difficult due to the valence shell of these elements having three electrons, that is, in p orbital one electrons are present, and in 2s orbit two electrons are present. These are the total number of valence shell electron is equal to 3, except from boron from the hydrated ion readily in aqueous solution due to very large value of hydration energy. Due to large value of ionization energy, due to loss of one electron in heavier elements, gallium onward, only the electron remain in ns orbital. The ultimate cell contains 18 electrons. In such ns2 pair becomes an inert pair and its removal becomes very difficult. Thus, on moving due to from boron to thallium, the stability of plus 3 state decreases and that of plus 1 state increases. Consequently, gallium shows plus 1 is moderately stable, whereas thallium in plus 1 oxidation state is more stable. Here boron, aluminum, gallium shows plus 3 oxidation state due to inert paired electron. This indium and thallium shows plus 1 oxidation state, plus 1 oxidation state, plus 1. Now the next topic is hydrides of boron. So boron form a number of hydrides having the general formula BnHn plus 4 and BnHn plus 6. The compounds of boron and hydrogen are called boranes. These contain special type of bonds known as multicenter bond. Here these are the one example. These are the sodium borohydride NaBH4 plus aluminum trichloride to give AlBH4 by 3 plus 3 NaCl. These are the boranes or hydrides of boron. Hydrides of boron means the hydrogens are directly attached to the boron by bonds multicenter bond. The another example is diborane, that is B2H6. The another examples of hydrides of boron is diborane, that is B2H6 or BH3, or simply called BH3. Now the oxide and hydroxide, all the elements of group 13 from oxide form oxide of general formula M2O3. For example, B2O3, Al2O3. The oxide of boron is B2O3 and known as boric oxide. Here twice H3BO3 to gives B2O3 plus 3H2O. These are the boric oxide. The oxide and hydroxide of boron are weakly acidic and therefore react with alkali, that is B2O3 plus. These are the base alkali NaOH to give NaBO2 sodium metaborate. Now the next oxo acid, boric acid, also called as boric acid. Among the oxo acid of group 13 elements, orthoboric acid BOH3 or H3BO4 is important. Some boric acid are known for, that is ortho